Hello everyone, I have a question here from my book. It is a question very similar to Max A 2014 question 1.4. Okay, really similar, but I even think this one is harder. I have in the picture two question 265 and 266. The 266, just ignore it, okay? We are going to solve 265. I just didn't know how to cut it. So this question is from my book. It's in Portuguese, so the name of the book is Fundamentos de Matemática Elementar, okay? Volume 8, question 265, okay? So let's read the question together. Find the point on the curve, this curve, that is in the minimum distance to the point -2 to -4. So look, the curve that he is giving you is x minus 3 squared plus y minus 6 squared equals 20. So if you remember from analytic geometry, circumference, if you have ever said, this is the center, the points of the center, right? So this is a circle with a center 3 in x and y is 6, and this is the radius square. So our radius is equal to the square of 20, okay? So that these are informations that are helpful. So look, basically what we are being told, so let's say that here's 3 and here's 6, so we have some circle over here, and then we have the point -2 -4, so the point -2 -4, so over here, right? Over here maybe -2 -4, okay? So he wants to find this point over here. What is this point over here that has the minimum distance to this point, okay? And it is on the circumference. So first we are going to solve it without calculus, and then we are going to solve it with calculus, okay? So this is the point -2 and 4. So just something, and if you don't remember the circumference, guys, study it, but be sure when you are going to pick the center that you don't pick -3 over here, okay? So if let's say if it was x plus 3 squared, then the center would be -3, okay? So just don't commit this mistake. If you did this mistake, take a book of analytic geometry and do many questions as you can, because you can't be doing these questions, these mistakes. If you are making this mistake, is because you didn't understand it well yet, okay? So this is -4. So this is the point, and we want to find this point over here. So first of all, I'm going to find the equation of the line that goes through this point and the center, okay? So the center and this point over here. So the way that I do this is I say that y is equal to ax plus b. This is the equation of a line, right? So now I'm going to take the first point, 3 and 6. So y is 6 equals to a multiplied by x is 3 plus b. The second point is -4, a multiplied by -2 plus b, right? I just took these 2 points. Why did I take y equals to ax, not ax squared? Because I want a line. I don't want a parabola, right? So I want a line. So let's subtract here both of them. So b minus b equals 0, so we cancel the b, and then 3 minus -2 is 5, right? So 5a is equal to 6 minus -4 is equal to 10, so a is equal to 2, okay? So what about b? Well, let's put a over here, okay? So a is 2, right? So we will have that 6 is equal to a is 2, 2 multiplied by 3 is 6, so 6 plus b. So 6 goes to the other side, so b equals 0, okay? So b equals 0. So the equation of our line was y y is equal to a, which is 2, multiplied by x plus b, which is 0 here. Okay, so now we have the equation of our line. Okay, this line over here. Okay, so now I'm going to put the equation of this line in the equation of the circumference so that I can find 2 points. Which 2 points? This and this point. Okay, because this line cuts the circumference in 2 places. Okay, so I'm going to find both these points. Okay, so and then we are going to choose the one that has a smaller x to be the closest. Okay, so this is my plan. So this is another point. So remember, what was the, we had that x minus 3 squared plus y minus 6 squared, right? But in the place of y, I'm going to put 2x. Okay, so 2x minus 6 squared is equal to 20. So x squared minus 2 multiplied by 3, 6x plus 9 plus, now let's do this part over here, 2x squared, so 4x squared minus 2 multiplied by 2 is 4, multiplied by 6 is 24x plus 36 is equal to 20. So x squared plus 4 squared. In this part over here, guys, I just took this part squared. Okay, so I didn't do anything fancy. This is why I did it fast. So 5x squared, this with this, this with this. Okay, now we have minus 6 minus 24 minus 30x. Now we have plus 9 plus 36 minus 20, right? Because this 20 will go to the other side with a minus sign. Okay, so 36 plus 9 is 45, minus 20 is plus 25. Okay, so this 25 is 9 plus 36 minus 20. Okay, this is where this 25 came from. From where did I get the minus 20? Well, because this was equal to 20, a big ugly 20 that I wrote over here, that this 20 goes to the other side, subtracting, right? So equals 0. So look, as I told you, we are going to find two values of x. This is a quadratic formula. It is giving us two values, which is to be expected because the line is cutting this circle 2 times. So let's divide everything by 5. So x squared minus 6x plus 5 is equals to 0. So let's find the root. So 6, let's do it. So 6 squared, 36 minus 20 divided by 2. Okay, so this is just minus b plus or minus the square root of delta divided by 2a. Okay, quadratic formula. Okay, so 6 plus or minus 36 minus 20 is 16, and the square root is 4 divided by 2. So we have two values. X1 is equal to 6 plus 4 is 10, divided by 2 is 5, and our second answer is x2 is equal to 6 minus 4 is 2, divided by 2 is 1. Okay, so see, this gives us both of the values. He is telling us that it is cutting here in 5 and here in 1. We are going to choose 1. Why? Because it's the closest one. Okay, so this is why we are going to choose this. X is equal to 1. Remember, from where did we find x equal to 1? We made a line that goes through the point that we want to find the distance from it, this point over here, that goes through the center. Okay, we found the equation of this line doing this, we found the value of a of b, and then we found the equation of the line. Okay, so for every y, this is the 2x, and then we put the value of this 2x in the circumference. Why? Because this y is part of the line and we want to find when it is part of the circumference. It is part of the circumference in 2 times, and these are the values. Now look, y is equal to 2x, right? So let's use it. So y is equal to 2 multiplied by x, but what x? This x is equal to 1. So our y is equal to 2. And this is our point. So 1 and 2. Okay? So now I'm going to make another video solving it with calculus, okay? Just one thing, what if he asked you not the point but the distance? So look, what if we had this our circumference over here, right? This was our odd point, okay? So what if he asked you the minimum distance, this distance over here, as the question of the max did? How can we find it? Well, look, it's actually much easier because it's not a line now, it's a point. So we can find the distance between 2 points, okay, and then we subtract the radius. What am I trying to say? Look, distance from 2 points. This point was what? 3 and 6, right? This point was -2 and -4. It forms a triangle. We can do it by the Pythagorean theorem. So look, this value over here, this value is 6, right? And this value is 4. So this side of the triangle is 10. This value over here is 2. And this value over here is 3, right? So 2 plus 3, this is 5. So what is the value of this one? Well, x squared is equal to 10 squared is 100, 5 squared 25. So x equal to square root of 125. So x is equal to the square root of 125 is equal to 5 multiplied by 25. Okay, so x equal to 5 square root of 5. Okay, and now what was the value of the radius? The value of our radius was the square root of 20, right? But 20 is 4 multiplied by 5. So our radius is 2 square root of 5. Now look, remember, our distance is the total minus the radius. So d is equal to x minus r. D is equal, x was 5 square root of 5 minus r 2 square root of 5. So d would be equal to 3 square root of 5. So he didn't ask us this in the question. He asked the point, but if he did, and he did in the maxed exam, so he asked you something like this, so but in the question of the max it was a line, so I thought it would be helpful to do this here too, okay? So try doing this question by yourself. Now I'm going to solve it by calculus.